Good morning. As I promised you yesterday, I'm making this video and try my best, even though David Hoff did an excellent job on two videos showing you the component of the components that we have used in the lab kit, as well as the second video try to do some wiring connection. So I decided that maybe I make a color coded diagram here and go through them so you really understand what's going on. Okay, before we try to do any wiring, we really have to understand these wiring diagrams very good. Let's start from the box that you have in front of you. Please open up the lab kit, put it in front of you. You could see there is a three switches: green, blue, red, and two lights, green and red. Identify them. So put your finger on it so you know what I'm talking about. All right. Then to the left of that, you see the terminal block. It's very important to understand what this one does. They have wired the lower portion, the one toward the case. Don't touch those wires. So any wiring that you need to do should be done from the top end of that. Okay? Now, let's take a look at the legend that David provided you. Okay, there are four red screws on each side. Again, don't touch anything at the bottom, just the top. There are four red switches, or screws, I should say. I'm sorry. The block is in red. The screws may not be red, obviously. And then the next to it is the other one with the white block. Since I could not write white on white, I use the brown. So anything you see brown here is really white, if you would. Okay. Now, all these are numbered starting from the far left of the terminal. It says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you count them, there are exactly 15 screws on the top that you have to use to insert a wire straight in it, get the screwdriver and tie it and secure that. Okay? Now, what are these? Let's take a look at the direction. The terminal 1 and 2, which means this screw and that screw next to it, is for emergency stop. A wire comes in one side to the emergency stop and then exit from the other one. Quite honestly, doesn't matter which one to come in and which one to exit. As long as you come into one of them, the one number one, and exit from number two. See how nicely I put? This is number one. They line up together. Number one, the current is drawn in black arrow. So anywhere you see black arrow means the current comes in. So the current comes into terminal 1 and exit the terminal 2. See how easy it is? Likewise, for the lights, let's work together. The red light has two terminals, number 12 and number 13, right there. Again, a current comes into the red light from 13, go through the lights, which is here, and exit from 12, which when we say common, we either come in if there is multiple branches going off, or if you just come in and get out. We usually use the common to get out. But again, these are not electronics components that you must come in at the right side and exit at the right side. These are electrical components. They are switches. They two blades touching each other. It doesn't matter whether you come from here and exit that way or the other way around. So really doesn't matter. I just want you to understand what's going on. Now, these three momentarily switches are for the on-off, normally open, normally closed switches, okay? All right. So you could use them anywhere within the diagram. So we have to understand, for example, let's take a look at the terminal 3, 4, 5. 3, 4, 5. That is called momentarily switch 1. Momentarily means is a push button. You push it, let go. Push it, let go. Okay? Now, there are three terminals used. 1, 2, 3. For this one, 1, 2, 3. For this one, 1, 2, 3. So a momentarily switch that one side of it is normally open, the other side of it is normally closed, use 3 wires. Okay? And let's take a look at momentarily switch number 1. A current is always coming to the common terminal, which is number 4. So you must come in to terminal number 4. Don't come to number 3 or 5. In this case, a current coming in, and it could go either this way or that way. So if you have a choice going this way or that way, come in from the common area, and we clearly identify the common of these momentarily switches, okay? So you coming in to number 4, and if you take the normally closed part of it, you are exiting from number 5. So you're coming into 4, and then you are exiting number 5. Okay? Now, if you press the switch, momentarily means push button. If you press the switch, what happened? That blade swings to the other side. So this normally closed will open up, and this normally open will close. So when you put your finger on a start push button, either the green or the blue, for example, by pushing it, what you are doing, you are moving this blade manually from this position to that position. It's like a swinging, if you would. It swings back and forth. So it will still receive the current coming in from terminal 4 by pushing it and, let's say, holding it for the time. The current that was going to terminal 5 will discontinue, and now the current goes through terminal 3 odd, coming in to the switch in common terminal number 4, exiting either at 5 if you don't touch the switch, or if you press the switch, it will exit terminal 3. So these are very simple material. It may be a fancy name momentarily, but just a push button. Push, the common coming in, the current coming to the middle one, the common, you notice we put the common in the middle of the 3, and then exit from one or the other. If you want normally closed, exit the one below it. If you want normally open, exit the one above the common wire coming in. See how easy it is to understand all those? Okay. So we did talk about the switches. We did talk about the lights. We did talk about the momentarily. Let's talk about the motor starter itself. The motor starter that you are using is a DC magnetic motor starter, meaning there is a coil sitting between A1 and A2, and that uses 24 volts to energize. Okay? So it's a DC motor starter. So you have to hook up, and this one, the circle you see here, M1, represent the whole thing here, motor starter. And the motor that you see sitting in the suitcase, if I should call it, is MTR. That's a small, tiny motor itself. So let's not confuse the motor starter and the motor itself from each other. Okay? All right. Now I'm ready to apply this control diagram to the component that I have. Okay? Now, here we put a power supply and we said plus minus 24. You don't want to touch the power supply. It's on the upper right corner. There we said don't touch any of those or the wiring of those. Instead, we brought this 24 to below here, and we brought that negative, the neutral, to below here. Don't touch the below part. Now, if I want to go from here to, and it passed through the fuse actually, we passed it through the fuse and we brought it here. So you really start from right here after the fuse. This point is any of these four red terminals that we have. So if I was to draw a wire away from here, I use any of these four screws. They are all tied up together. Okay, so it doesn't matter which one. And you don't have to start with one. If you decide to start with three, go ahead. They're all interconnected to each other. So the juice comes from the below, from the power supply, and you take it from the above and go to your component. Okay? So I need to go to my stop. I have to identify the stop on the terminal block. Okay? And the stop is the one normally closed. So I have to pick the red switch, which is normally closed. All right. So I have to decide which one to use. There are three switches and there are three momentarily. So it's really up to you which one to use. So you could select either number 1 or number 2 or number 3. Let's call it number 1. So I'm using momentarily 1 for my stop. So this is my stop, if you would. So I'm using that. Okay? Now, we said what? We said the current comes into the common area. Common area is terminal number 4. So I take a blue wire. This is 24 volts hot, we call it. So I take a blue wire, go from number here, this is where the juice is coming out, and I'm going to number 4. So where is 4? This is 4. So I'm coming from number 1. Let's call this one number 1 of hot. And this is number 4 of a stop. You see, 4 is the incoming, the common. So I go from number 1 piece of wire and tie it to number 4 of this block. So I took care of this wire as you see. All right. Now I need to get out from the other end of the stop. But stop is a normally closed contact, meaning if you don't touch it, the current will pass through it. Don't touch it. And I don't want to touch the stop to begin with. So the question is, I came into number 4 of this momentarily switch. Should I exit from 3 or should I exit from 5? You have to look. If 4 and 5 is called normally closed, 4 and 3 is called normally open. Since I want a normally closed out of it, I must exit number 5. So I exit number 5. So I put 5 here. So it would be very nice to number the diagram with the terminal number so you can easily connect them. Where am I going? I'm going from 5, which I exited. So this is arrow going in. This is arrow going out. The current goes into 4 and exit from 5. Okay? Now where am I going? I'm going to another momentarily switch, which is allocated for a start. I cannot use this one no more. That number 1 has been used. Don't touch it no more. You don't need it. So you have a choice, either get this one or that one. Again, you could take number 3 if you want, number 2. They don't have to be in order. But anyhow, so let's get number 3 for the fun of it, if you would. All right, so we call this one 1, let's call this one 2, and let's call this one momentarily number 3. So I decided, not being forced by, I decided to use the momentary number 3 for my green start push button. Now, if I had a second start push button we don't have in this lab, we will have later on, I can use momentarily number 2. At this time, don't touch momentarily number 2. Okay, so how do I come in? That is the question. In momentarily switch, you're always coming from the common area. So I took this one as my green start. Let me color code it. Start. I decided to go with number 3 momentarily switch. Let me change this one to green number 3 to be color coded. So I have to exit a stop, enter a start. So since I selected this one to be my momentarily switch, I am now coming into terminal 10. So terminal 10 is here. So I'm coming from here to here. Okay, so 4 and 5 was considered a stop. So I better write between these two. These two were a stop. You see how nicely I numbered them? And let me number them with red because you usually use red color for stop. 4 and 5, here is 4 and 5, and I wrote a stop on the piece of paper so I know what I'm doing. So I came from 5 to number what? I came from 5 to number 10 of the start. So this is 10. I put the 10 here. Oh, it should be green because I'm using green. Really doesn't matter, but I'm trying to color code them as much as possible. All right. Forget about this for the time being. Let's go across. Then I have to get out from the other side of the start. The question is, I came into number 10. Should I leave number 11 or should I leave number 2? I have number 9, I'm sorry. I have 2 choices. Well, we look at this one. This is normally open. So when you come into the common terminal 10, you must exit from number 9 because between 10 and 9 is sitting your normally open contact. So don't exit 11. You're going to be wrong. So I'm exiting number 9. I'm still using blue because there are voltage and current in that wire. 24 voltage plus whatever the current the motor started and all those required, okay? So I'm exiting number 9. So I'm gonna put 9 here, clearly define the exiting terminal. And where am I going? I'm going into A1 of the motor started. So I'm exiting 9 and I'm going to A1 right there. See how nicely it is when you number them and follow the diagram. So loosen up the screws, put the wire in it, tighten it. Piece of cake. Make sure you select enough wire length that you don't have to pull it. Hey, boy, come here, get this wire, we have to stretch it. No, we don't want to do that. On the other hand, we don't want to pick a long one that go twice around the house and come back in. Reasonable. And as David said, if you should run out of wire, call a school and they give you, but try to be conservative. Okay, so here is my A1. Now, between A1 and A2, there is a coil sitting. Remember, we keep saying coil of the motor starter. This is where the coil is sitting inside. So when the current reaches the coil, it drops the entire 24 volts. So this 24 volts that is coming will be dropped 24 volt DC will be dropped across the coil completely. So up to A1 we had current and the voltage coming in. Now that I'm exiting A2, the current is the only thing exiting. We never lose current. Whatever current comes from the source must return. But we are losing all the 24 voltage across the coil. And now that I'm exiting the coil from A2, since I no longer carry voltage, just the current I carry, I have to change the color of the wire. That's why electrician says solid blue that we've been using means current and voltage. 24 in this, if it is AC, 120 volts, but we are in DC. So these solid green wire, blue wires I'm using have voltage and current at the same time, okay? Now, when I drop the entire 24 volts across the coil, then I use a white with the blue trace, David call it. I usually call it the blue, white and blue stripe, but same thing, makes absolutely no difference. So that's why I changed the color. You see, up to this moment, everything is blue. Everything from 24 that you exit from here, this point is here. You come through here, through the stop, through the start. They are all solid blue wire. Now I exit A2 and let me use the appropriate color. I'm no longer using blue. And where am I going? I'm going to overload of the motor starter. Here is 95, here is 96 of the overload. So this is overload side. So I'm exiting A2 and going to 95. There you go. See, nicely numbered so I know what I'm doing. Get a small piece of wire, go from here to there. And then I'm exiting 96 since again, the only thing I carry at this time is current, no voltage. Don't use blue no more. Just continue with white with the blue trace on it. You exit 96 and where am I going when I get out of 96? I'm going to the neutral right there. Remember, this is plus minus 24 volts DC. Here is my plus, here is minus. We don't want you to touch the power supply. That's why we wired these two wires down here. So you start from there. See how easy it was connected? All right. Now for this part, as we explained in the other lectures, that when you press the start, as long as you hold it down, the juice makes it to the coil and the coil is energized. Now, if I let go my finger, this spring-loaded normally open will open up and the current drop dead. The motor starter gets de-energized and the motor will not come on anymore. So we have to use the so-called auxiliary contact. Here is the auxiliary on the top of the motor starter. I don't have the diagram actually in front of me. If I did, or itself, not the device itself. So pick up a multimeter, put it on continuity, and then while no voltage is applied, by the way, when no voltage is applied, just pick up your multimeter. I know there are two of them normally open contacts, the other two normally closed. In AC, I know the first and the last are normally open. The two in the middle are normally closed. But I don't want to say something that since I don't have access to it, I cannot measure it. So pick up your multimeter, put it between these two legs. If it beeps, it's normally closed. If it doesn't beep, it's normally open. Move over to the next, move over to the next, move over to the next. Those which are beeping, identify them as normally closed. Those who do not beep, identify them as normally open. Let's assume, this is assumption. I don't want someone to come and say, oh, you drew it to there and I did it, didn't work. So after you identify is open or closed, then you pick up the blue wire again, because this is before the coil, so it has to be blue. So I'm going from number 10. Here's number 10. I'm going to one side, and let's call this one P and Q. Since I don't have number, I cannot give a number. I just call it P and Q. So I go from number 10, which is here on the block, to P. So put a piece of wire here and go to P. And this is exiting and entering here. So I took care of this piece now. Then take another blue, because it has voltage and current, come out from Q, okay, which is this one, and then go to number 9. So come out of Q and go to number 9. As David said, any screw should not have more than 2 wires. Don't twist several wires together. Any single screw can have at most 2 wires. If you need more, something must have gone wrong. So you did that. Now let's go back and operate it. I press on the start. The motor starter gets energized. The plunger pulls in. This one will close now. The auxiliary contact closed, and when auxiliary contact closed, now the current that was coming to 10 continue, goes to P, come back to Q, and make it to 9. So you could let go your finger. Okay? That's very easy. So this is how you need to wire it. All right? Now, if I need to add a light, I did not ask you for the project one, what we will do. So there are 2 lights you could use, red or green, and then you could use the remaining auxiliary contact. For example, when the motor is on, I like to put the green light on. So I'm gonna add, again, this is not part of project 1. I'm done with project 1, but I'm gonna guide you to the new projects that you will see. They say, okay, now let's add a green light. When the motor is on, the light comes on. Okay, no problem. I'm gonna pick up a blue again, wires, and coming from here, and then I go through an auxiliary which is normally open. That was also normally open. That's why they give you at least 2. So if you already use P and Q, now you could use S and T, for example. Okay, so you go to S, you get into S, exit the T, and then go to the green light. Where is green color? Green? Here it is. And then, again, I drop the entire 24 volts across my light bulb. and I don't have any voltage coming out, only the current. That means I have to use the brown color. See, all the brown color line up together, all the blue colors line up together. Okay, so how do I do that? I decided to pick P and Q. So I go from another hot. You see, this line going down is the continuation of hot. That's why I use a different wire from terminal number 2 of the red. There are 4 of them, so you can use multiple of them. Go from here to, go to S, and here is S. Exit from T and go to one side of the green light. Green light again. You could come to terminal 15, exit 14, or come to 14, exit 15. Really doesn't matter. So I'm exiting T and going to 15. Okay, so I put 15 here. And now I have to get out from the other side of the light. The common is 14. So I get out of 14, but again, I lost all my voltage across the light bulb. I have to change the color to white with blue trace on it. Come out of the common number 14, which is this one, and return to the negative of the power supply, which is this one. You see how nicely we put 4 of each so we can continue using them. So this is really simple projects, honestly. There are 9 of them. Like I said, I'm expecting you to do 1, 2, 3 by Monday, and then next week and the following week, we want to make sure we get all 9 of the projects you have received. So very important. I suggest you take a picture of this, so, and therefore you can see it. Let me step aside the camera so everything hopefully is well focused. I can see it. Let's see, I have to stay one side of it to remain focused, I believe. Okay, I think that's good. So take a couple of good pictures. So anytime you need to go back to see it, you don't have to visit the entire video. Just as a reference, you can check the picture. Now, please let me know if you have any problem that you have. I believe I explained it good enough that if you listen carefully and while you are wiring, just put the tape and follow the instruction and then flip the switch. The rest of them, David explained. There is no need for me to go to the rest of them. Make sure you unplug your cord before you do all the wiring. Once everything is done, plug it back in. Don't be scared. If something goes wrong, the most probably you blow a fuse, and fuses are 30 cents a piece. You could buy it yourself or ask from a school. So don't be scared. Take the charge and do a good job. And if you obviously have any problem, write one email away, and I'd be glad to answer any question you have. Good luck. So I want project 1, project 2, project 3 for Monday. When we get back together Monday, I ask you if you did it or not. And if not, well, I come back to California and we will see. Very good. Good luck. Have a wonderful weekend. And please work on these projects and Monday report to me if you have any problem. If you have any problem, write it down. I got lost here, or I didn't get what you said, or why, and then we can talk it over. Have a good weekend.